So now we're going to look at a couple different types of special logarithms. One of those special kinds is called common logarithms. Logarithms with base b equals 10 are called common logarithms. When no base is indicated, log is understood to mean log base 10. So let's go ahead and do some of these simplification problems. In A, we want to simplify log 10,000. So when I see log of 10,000, it's understood that that's log base 10 of 10,000. And what we're going to do to try to figure this out, we're going to translate to exponential form. So we want to let our log base 10 of 10,000 equal some variable x. And then we can rewrite this as an exponential. Base 10 to the x power, 10 to the x power equals 10,000, the number inside. So we just need to know when no base is indicated, with log, it's understood to be base 10. 10 to the x equals 10,000. I can rewrite as 10 to the fourth power. Bases are the same, so x has to equal 4. And that's what log of 10,000 is equal to. Log of 10,000 is equal to 4. Next one, B, log of the cube root of 10. So I can rewrite that as log base 10 of the cube root of 10. And I'm going to let that be equal to x so that I can rewrite as an exponential. Again, I have 10 to the x power equals the cube root of 10. I want to try to write both sides with base 10 if I can. I can say 10 to the x equals cube root can be written as 1/3 exponent, so that's 10 to the 1/3. My bases are the same, so the exponents have to be equal. X is equal to 1/3. So log of the cube root of 10 is equal to 1/3. Now this next problem's a little bit different here. I have 10 to the log of 2.5. To figure out what this is equal to, I'm not going to set the entire expression equal to x. I'm just going to let the log of 2.5 equal x. Just the log in the exponent. I'm going to think about what that means. So that's log of 2.5 is equals x, means 10 to the x power is 2.5. Okay. But what do we want? We actually want, we don't want to know what x is here. That's my little twist on things. We want 10 to the log of 2.5. We actually want 10 to the x power is 2.5. That's our answer. Not x, but 10 to the x power, because I let x be equal this exponent expression only. So here we get 2.5. So a little twist on things. That we're not solving for x, but 10 to the x. There's another special kind of logarithm, even more important, in fact, much more important than common logarithms, are natural logarithms. Natural logarithms are logarithms written with base b equal to that number e. Recall that e is a constant. E is about 2.7. It's the base of the natural exponential function, so its inverse is called the natural logarithm. When we have log base e, that's usually written as ln, just 2 letters is the abbreviation for that. So let's do some problems here where we simplify. Ln of 1 over the square root of e. So that means log base e of 1 over the square root of e. I'm going to let that be equal to x, so I can rewrite as exponential. E to the x power then is equal to 1 over the square root of e. E to the x is equal to, that's 1 over e to the 1/2. And that 1/2 in the denominator, I can rewrite this as e to the -1/2 on the right-hand side. So I got same base. That means the exponents have to be equal, so x has to equal -1/2. And here, x is what we want. We wanted to solve for x. This ln of 1 over the square root of e is equal to -1/2. In b, I have e to the ln of 3. Now, here, this is similar to that last problem from the previous page, where I'm not going to let x equal this whole thing. I'm just going to let x be the ln of 3. So x is equal to log base e of 3. E to the x power is 3. Now what we want here isn't x. We want e to the ln of 3, which is e to the, I called x ln of 3, but e to the x is 3, and there we got it. E to the ln of 3 is 3. And finally, one more here, ln of 1. Ln of 1 is log base e of 1. We can let log base e of 1 be x. So e to the x is equal to 1. We saw an example of this before, where what we can do is we can think of that 1 as e to the 0 power. I want to use base e if I can, and anything to the 0 is 1, so here x is equal to 0. ln of 1, 0. I also want to say something about calculator use, because we've been doing a lot of this evaluation by hand, but really when logs come up in applications, and we'll see this pretty soon, we normally can't figure them out by hand. We have to use a calculator. So I just want to talk a little bit about making sure that you can find buttons on your calculator to evaluate both log, log base 10, and ln, which is log base e. Most scientific calculators have both of these as buttons on them. And so here's my very inexpensive little scientific calculator. I have an log and an ln button. So all I'm doing is pushing buttons here. So log of 0.00001 is I guess I gotta turn mine on, clear, 0.00001.401, and then if I hit LOG, -5 is what I get. That's actually one we could have figured out by hand, but I'm using a calculator here. LOG of 3.5, just 3.5. I just push my LOG button. Now I'm going to have to round this off. This is about 0.544. Also, I have ln of 1, and well, we already know what ln of 1 is. We just did that in C, but let's test our calculator here and see if I put in 1. And now I have an ln button, so if I hit ln of 1, sure enough, I get 0, so that just confirms what we already figured out by hand. But now ln of 3.5, if I hit 3.5, and then use my ln button, I get, again, a decimal I'm going to have to round off. That's about 1.253. So notice that LOG of 3.5 and ln of 3.5 are totally different on the calculator. And one more section I want to talk about in this video is a few properties of logarithm. We're going to start with that equivalence between an exponential expression and a logarithmic expression. So I'm going to say b to the y equals x. That's can be rewritten as a log base b of x equals y. The exponent goes by itself on the other side of that equation. Now, we're going to take some things we know. So for instance, we know for any base, b to the 0 power is 1. So I can rewrite b to the 0 power as an expression with logarithms. That's log base b, inside would go the x, so of 1 is equal to 0. Log base b for any base of 1 is equal to 0. We also know b to the first power is always equal to b. Any number to the first power is itself. So log base b of, in this case, b is equal to 1. That's true for any base. And just a few examples of that. So if I say log base 2 of 1, that's got to be 0. If I say log of 1, which is understood to be log base 10 of 1, that's got to be 0. If I say ln of 1, that's log base e of 1, that has to be 0. Those are all examples of this log base b of 1 is 0. If I say log base 2 of 2, that's got to be 1. Because if the base and the number inside match up, we're always going to get an output of 1 from the log function. Log, let's see, if I write log, its base is 10, so log of 10 is 1. That's log base 10 of 10. And ln of e, log base e of e, is also going to come out to be 1. So those are some examples of the two properties in the box. Also, f of f inverse of x equals x, and f inverse of f of x equals x for functions and their inverses. So let's let f of x be b to the x, then f inverse is log base b of x. When we write f of f inverse of x equals x, for these functions, that's like taking f of log base b of x and saying it's equal to x. But the f function is b to the x, so that's like taking b to the log base b of x power, and we get x back. So raising to the b power and taking log base b, in a sense, kind of cancel each other off. If I write this composition with the inverse on the outside and f on the inside, I have f inverse of b to the x has to be equal to x. F inverse is log base b of b to the x equals x. This is a composition of log and exponential functions that's also always going to take us back to x. And just a couple examples of these. So if I wrote 2 to the log base 2 of x, that's always equal to x. They cancel out. 10 to the log of x is equal to x. E to the ln of x is always equal to x. Some examples. This property, also the log base b of b to the x, we can say log base 2 of 2 to the x is always equal to x. Log of 10 to the x, since that's log base 10 of 10 to the x, is always x. And ln of e to the x, log base e of e to the x, is always x. Whoops, sorry, went down off the bottom of my sheet. So I'm going to have to lower this to get the 4 properties on there. I just want you to see these at the end. So 2 at the top. We'll sum these up a little later on, but I wanted you to see these already at this point. The 2 at the top, the 2 more kind of complicated ones at the bottom. And that's it for this segment.